In this video, we're going to talk about constants in C. So there's three types of constants we want to talk about. The first we've seen before, and that is a symbolic constant. You'll also see that sometimes referred to as a preprocessor macro, where we use hash define num to be 10. We've also seen enumeration constants, so that's an enum type. We can either allow those to get a default assignment to a value, which we'll see here, or we can specify what we want each of those values to have. And this gives us an enumeration type where we can use 1, 10, 11, or 20 as constants in our code. I've also declared a variable here that we'll use later. The third type of constant we want to talk about is a constant variable. Now, hopefully you see that that's sort of an odd name for something. How can it be both constant and variable? And that's something that we will get into. So I can create a variable called I, and I can assign that to be num, which is a symbolic constant. I can also have a pointer to my constant. I can have a type of the enumeration, or a variable of the enumeration type. And notice I'm assigning it to be 20 there. And then finally, I can also have a constant pointer. I might say, isn't that a fourth kind of constant? No, this is just a constant variable. The type of the constant variable is integer pointer. And I'll assign that to be my int. So let me put in some code here to just print those values out. And I'll just dump that in so that we don't have to waste time typing it. Okay, so there we go. We have some, we're printing I, we're printing J, we're printing everything's addresses, where they are in memory and so forth. Also, you'll see that we can print num, 1, 10, 11, and 20. All of those are constants. This is our symbolic constant, and these are our enum constants. So let's compile that. And you'll notice we get a warning. Initialization discards const qualifier from pointer type. So we have 14. So my const is a constant, and so it wants J to be a constant pointer. And that should make sense, because once we have this pointer to a number, if we use J to modify that value, we lose the constant property of that myConst variable. Now, a couple of things are not allowed because of these constants. Notice it did actually give me a warning there, but it allowed me to do them. So these things are not going to be allowed. And we'll do them one by one. And then when we're done, we'll move them inside of there. So myConst is a constant. And notice I'm trying to increment a read-only variable. So I'm going to take some time and edit this to where it's just one line of code, just so that we can see a little more at the same time. So, okay, that looks like that'll do it. And then let me make this a little taller. So you can see that myConst is a constant, so we can't increment it. So into the not allowed pile it goes. We can't do 10 plus plus, we can't do num plus plus. And you notice both of those, we get the error, and L value required as an implement option. So no go there. How about if we do this? 10 is equal to 21. We get the same error. We again, we can't do any sort of assignment with those enumeration constants. How about if we dereference p and then increment that? So p is just to my int. My int is in a constant. Again, we're incrementing a read-only location. Since we're using a constant pointer, there's no trouble at all if we just did my int. But so you see, we got that same warning for the constant qualifier. We'll get rid of that in a little bit. But this is perfectly fine. But when I had a pointer to that same value, I'm not able to increment it because the constant pointer says you're not allowed to change. And then finally, let's try this. So I've taken the address of my const and then dereference that. So the thought there is maybe now this isn't a constant, it'll let me change it. And no, again, we get the same thing. Once I dereference, I get an alias to that constant variable. So this is also not allowed. Now what is allowed, I could do something like this. Looks like I didn't save the change. So j is a pointer and it's pointing to my const. So let's do j and let's do my const. Once we've done that. So now you see j is now 21. It was 20. My const is 20. I've actually changed the constant, but to do that, I have to ignore the warnings. Again, you should always try to get rid of your warnings. If I make that a constant, now there's no warnings. I'm getting an error that I tried to increment a read-only location. So but I'll make a note here that will be allowed if j is not a constant pointer. You get warned, and so if you ignore the warning, sure, it'll let you do it. I can also say that p is equal to the address of my const. Again, that's just because that's a constant pointer. So this is just some things about constants that you may be interested in. One thing to keep in mind is that anytime you're working with a parameter to a function that's not going to change or that shouldn't change or shouldn't be changed in the function, always make it const. You don't lose anything, but by making it const, you ensure that that pointer won't be used to make changes unexpectedly inside the function. It's also sort of a signal to anyone looking at that code that, hey, nothing should change with this through this pointer in this function or through this parameter.